Chemical kinetics is just a fancy way of describing how fast chemical reactions happen. And in the human body, speed matters. When body temperature rises, molecules move faster. That means reactants collide more often and with more energy, which speeds up reactions. For every 1 degree Celsius increase, which is about 1.8 degrees Fahrenheit, reaction rates can rise by around 10%. So during a moderate fever, say 102.2 degrees Fahrenheit, your metabolism ramps up. But if your temperature climbs too high, above 105.8 degrees Fahrenheit, proteins start to denature, and that's dangerous. The more reactant molecules present, the more chances they have to bump into each other and react. That's why giving extra oxygen to a patient with low oxygen levels, hypoxemia, can help speed up aerobic metabolism. Smaller particles or more exposed surface area means more places for reactions to happen. This is why finely ground or micronized drugs dissolve and work faster than coarse powders. Enzymes are biological catalysts that speed up reactions by lowering activation energy, and they're not used up in the process. They bind to specific molecules called substrates, using either the lock and key model, where the fit is exact, or the induced fit model, where the enzyme molds around the substrate. This positioning helps weaken bonds and line up reactants in just the right way. Enzymes often rely on metal ions or cofactors to work properly, and their activity is tightly controlled by the body. Every enzyme works best at a specific pH. For example, pepsin, which digests protein in the stomach, works best around a pH of 2, while trypsin, which is active in the small intestine, prefers pH 8. Even small pH shifts can alter how charged parts of the enzyme or substrate are, changing the way they interact and slowing the interaction. Once you understand these principles, a lot of things in physiology start to make sense, like why cooling the body during cardiac surgery slows metabolism, how acidosis interferes with enzyme function, or why a trace metal deficiency can throw off an entire metabolic pathway.